Okay, folks, welcome to lecture 4, and we're just going to have an introduction to fractions and then take a look at some of the basic operations like addition, subtraction, multiplication, division. So most of us are familiar with fractions, but just to kind of formalize it a little bit. So fraction, there's two parts. The top bit is the numerator, and that's the bit we have, the shaded bit. So we have three of them. The bottom bit is called the denominator, and that's the total number of bits that the whole is divided into. So parts we have over total parts. There's three types of fractions. There's the proper fraction. Proper fraction, the numerator is smaller than the denominator. So by definition, a proper fraction is always less than 1. Then there's an improper fraction. Some people call it a top-heavy fraction. Numerator is bigger than the denominator, and by nature then that's always greater than 1. And then there's mixed fractions, where we have a whole part, an integer part, a number part, and a fraction part. And often, guys, just to kind of get into the terms, often the word rational, if you see the word rational in terms of maths, it often is referring to a fraction, but there'd often be kind of letters and stuff in there. So this would be called a rational term instead of a fraction. The rules are the same though for both of them, but just to be aware, the word rational also applies to fractions. So mixed fractions, there's a whole number and a fraction bit. And these have to be converted into the top-heavy fractions in order to do any calculations. So these mixed fractions are actually not much use. So here, guys, I would take a look, have a go yourselves, just pause and see if you can turn this into a top-heavy fraction. But how you do it is we multiply these two values, and then we add the value on top. So I know that looks a bit messy. So it's 4 by 5 is 20. And then we add 3. So 23 is what goes on the top. And a quarter is what goes on the bottom. Now why we multiply here? Because we have 4 parts in a whole. We have 5 whole parts. That's what's given us the 20. And then we also have the 3 parts that live in the fraction term. Look at another one. So again, 5 by 3 is 15, plus 2 is 17 on the top, and 5 on the bottom. Another one, don't let the minus put you off. 8 by minus 1 is minus 8, plus 1 is minus 9. So the whole, this is very important, guys, the whole term is negative. So you just work with the number and the minus kind of sits outside. Don't be making things complicated for yourselves. So it's just minus this number. So you just work on the number with the same rules as before. And you also need to be able to go the other way. So say if you're given a top-heavy fraction, we need to be able to turn this into a mixed fraction. So really what you're doing is actually dividing. But we need our remainder. So 5 will go into 12 2 times, and 2 left over. So we're going to have 2 and 2/5. Lots of different ways of getting there. So there's the 2, guys. The 2 that we would normally carry is the remainder. Similar one, again, 8 into 27. If you kind of think of it, 3/8 is 24. We're only looking at that number. And then there's 3 left over, so it's 3. There's 3 left over. And that's our answer there. They should be level, guys. They should be 3 and 3/8 like that. Not sitting at the bottom the way I have it here. That doesn't look great, this first one. And to be really pedantic, they should be all the same level, actually, just to... I'm trying to teach you how to do things right. So really, that's a bit more correct. Okay, so just be aware, you need that skill. Generally, guys, I prefer a top-heavy fraction than a mixed fraction. The reason for this is, guys, is because basically this is just cosmetic. It's no good to us in terms of maths. If we want to do any maths with this, we're going to have to change it back into its top-heavy form. And you guys know just as well as me is that it's in these transitions that the errors will often occur. So personally, to me, this answer is just as correct as that one. This one is a little bit fraught with danger. And if you make a mistake, guys, say if you do make a small mistake and you end up with -29, you're going to lose marks, even though you might have had it right at the start. But if you write your final answer incorrectly, well, as you know in Moodle as well, Moodle will always do that for you as well. If you make a mistake, you get punished. So that, guys, is just converting in and out of mixed fractions. So you know the drill. I'll throw up a few questions, guys, so pause the video at the end. So pause the video and have a wee go at changing these. Remember what I said about the minus? The minus just sits in front of the whole thing. Work on the number. Okay, guys, so I'll let you have a go at those and we'll push on. Now we take a look at equivalent fractions. So an equivalent fraction is one that looks like another one. Sorry, doesn't look like it, but they do have the same value. So here we can see this is essentially 3 different ways of representing a half. If we look at it visually, we can represent it as 2/4 or as 4/8, but it's still the same thing. So that's what equivalence means, is it's 2 fractions that look different, but they have the same value. And we use this quite a lot then. We've already actually seen this, guys, with the division. Just to give you an example, say 2 divided by 0.05. We multiplied the bottom by 100 and the top by 100. And now this became a much more doable problem. But these are equivalent. Even though they look different, they have the same value. And even the 40 is equivalent, even though it looks different. That could be written as 40/1, and we'd have a fraction again. So equivalence, just like that briefly appeared, really means equalness. It's kind of not a word, but that's what it means. So as long as we multiply or divide, we're only allowed to multiply or divide. You're not allowed to add something to the top and add the same number to the bottom. That doesn't preserve equivalence. But as long as we multiply the top and bottom by the same thing, equivalence is preserved. So 1/3 is the same value as 10/30. Similarly, we could divide top and bottom by 3. And that would give us 8/12. And you can see again, guys, you don't really have to write it. You can see here, okay, 4 will go in here 2 times. 4 will go in here 3 times. So that's the way I always do it, is just divide top and bottom by the same number, and you still achieve equivalence as long as you're using the same value on the top and bottom, the numerator and denominator. And as long as you're multiplying or dividing, you're safe. So we always use this idea, guys. So this might be an answer you calculate on Moodle. You'd always be expected to bring the answer to its simplest form. And it just saves you a lot of calculations as you go along. So you always cancel as you can to make your life easier. So again, just another problem. So again, just pause the video once these pop up. It's probably not the best place to put that. I'll know that for future. So hope you get this and we take a look. So I just want you to reduce these down, guys. Divide the top and bottom by, you could see here 2 would go in top and bottom. And I think 4 would go in. Yeah, 4 would go in top and bottom. So keep going until you can't get the fraction to any lower. It might be, say, 3/7 or something like that. Same with the one here. Again, don't let the minus confuse you. Your answer is going to be minus. A little bit more challenging, but same principle. And another one here. So just have a go with each of them. And again, I'll just push on, but make sure you record your answers and have them close to hand when you're doing CA test 4. Now, this is something a lot of people don't realize with fractions. It's a very handy little trick. So say if we have 2 fractions and they're equal. What a lot of people don't realize is you can actually swap across the diagonals. So I could swap that 10 and the 2 and I'd still have a true statement. So you can see the 10 and the 2 have swapped, but this value here is 2 and this value here is 2. So that's still a true statement. So that essentially, as far as maths is concerned, that means it's valid. Similarly, I could swap across to the other diagonal. Swap the 4 and the 5. And again, on the left we have a half, and on the right it's still equal to a half. So that's also a true statement. So these are valid. If they work for numbers, then they're valid kind of transformations is what they'd be called. Now, you're probably going, okay, that looks great, but how does it help? When we're later on in the course, guys, you will come across problems like this that might look a bit tricky, and you're going, oh, okay. But if you actually swap the x and the 4, now it's suddenly a lot easier, and the answer can drop out quite quickly. So that's just a very simple example, but it's just a useful little skill if you remember it. It only works though, guys, if you have single fractions on each side. So say if there was a +1 in here or something like that, then you can't do this unless you turn your +1 into a top-heavy fraction with this, turn that into a single fraction, and then you can do it. So just, it might help you down the line. I will mention it again and again. It's just a very useful little skill. It's like a little backdoor that can often help you escape from a problem that could be tricky enough otherwise. Negative fractions. This is more about aesthetics. So if your fraction, it's okay, often guys you'll end up with an answer, and you might end up with, say, 3/-4. Generally, guys, you don't write the minus on the bottom. It's kind of bad manners in maths. You either float it to the top, to the numerator, or let it sit out in front of the fraction like that. I generally find it easiest. My advice would be to let it sit in the front. And then your maths is nice and simple. You know you're just dealing with a negative number, and everything will be more straightforward. But either of these is correct. If you write your maths like this, it shows you don't really know what you're doing. And all the time, guys, we're kind of trying to aim towards professionalism. So a few other skills. All whole numbers can be written as a fraction. So 5 can be written as 5 over 1 minus 3 minus 3. This can help us as we're working our way through some of the operations coming up later on. A variable can be written as a fraction. Even 0 can be written as a fraction, but be very careful, guys. This is okay where you have a 1 on the bottom. But if you ever have a fraction with a 0 on the bottom, this is undefined mathematically. And it tends to make mathematicians and physicists freak out a little bit. So be very careful, guys. If you ever end up with a 0 on the bottom of a fraction, you're essentially in a mathematical black hole and you will never get to an answer. So to be avoided at all costs, depending on what branch of maths you're into. But as far as we're concerned, we don't like zeros on the bottom. So just watch out for that. Decimals into fractions. This is just a skill you need. We've already looked at it. So how do we turn a fraction, fraction into a decimal first of all? How do we turn a fraction into a decimal? Simply as we've been doing it before, guys, not long division, short division. There's my divisor, sits on the outside. There's my 2. Bring in a rack of zeros if we need them. Drop the decimal point down here. Bring in more zeros if we need them, depending on what level of accuracy we're required to go. And then do your short division as before. So often in Moodle, you might be asked to express your answer to 4 significant figures or 3 significant figures, etc. So remember how to do that as well. Going the other way, guys, is not so straightforward. Say if I give you a decimal 0.6. Well, first of all, the easiest way out of these is to think, well, if I wrote this as a fraction and wrote it over 1, just like we were looking at, then I could multiply the top and bottom by 10. And that'd give me this. And now I can see 2 will go into the top and 2 will go into the bottom. So the neatest way of writing 0.6 as a fraction is 3 over 5. And again, guys, Moodle will always look for the simplified version. So please don't email me and go, oh, I got this and it's correct. It is correct, but you should always, I'm trying to teach you good form as well as everything else. Now say if we had 2 decimal places. Now really again, we can write this over 1. But if we want to get rid of all the decimal points, we need to multiply the bottom by 100 and the top by 100. And that's what gives us this fraction. And now we can cancel top and bottom. 5 will go into the top, 5 will go into the bottom. And that's 0.65 written as a fraction. So you can guess what's coming next. So write these fractions as a decimal, correct to 3 significant figures. And write the following decimals as fractions. So again, just pause the video, write down your answers, don't forget to log question 4.3, etc. And then your 4 answers, A, B, C, D, E, E, D. Shut up. Sorry. And now we're just going to take a look, guys. So that's kind of the introduction. That's just the bits you need to know when you're dealing with fractions, the principles and what to look for, what's expected. Now we'll take a look at the operations. So multiply, divide, add, subtract, and more. So we'll start with multiply. Normally people start with addition and subtraction. They're more difficult with fractions. So we'll start with the easiest. So multiplying fractions, guys, it's very straightforward. Multiply the top, multiply the bottom. And again, just like with the minuses, never write the multiplier just beside the denominator. You can either write them at the top or at the side. So top by top, bottom by bottom. If there's minuses in there, guys, then your answer is going to be plus. So all the old rules still apply. BODMAS still applies. If you have this, you still have to multiply first. So all the little rules we've been learning up till now kind of start to accumulate in some of these problems. When you're dividing fractions, this often causes a lot of consternation, but it's actually very simple physically as long as you remember what to do. You flip the divisor and multiply. So the divisor, remember we identified the divisor. In this case, it's a divisor, not a denominator, but it's still the same thing. Flip the divisor and multiply. And now it's still just top by top, bottom by bottom. So that's division. As long as you remember, don't flip the top one, the numerator, always flip the divisor. Now we'll take a look at adding and subtracting. So we need a common denominator, first of all. Before you can add or subtract fractions, they must have the same denominator. Otherwise, you can't do it. It's like adding ducks and geese. You have to turn them all into ducks or turn them all into geese or some other kind of hybrid. Call them all birds. So sometimes it's easy. So sometimes the denominators are the same. And it's very important here, guys. We have two of these things, 2/5, and we have one of them. So we're still counting fifths. We don't add the denominators. We just add the numerators. So I used to always say to students, it's like with sheep. If you have 2 sheep and 1 sheep, then you still have 3 sheep, not 3 sheeps. So you only add the top. And once you've got the same denominator, that's what sits on the bottom. So there's our answer. So sometimes it's easy, but most times it's not. So here something looks very similar. Sorry. But it's a completely different problem because the denominators are not the same. So first thing we need to do is find a common denominator. What number will 3 and 5 multiply into? They'll both multiply into 15. So this is what we now write. And now, guys, we go in and we simply want to change each fraction individually. So I'm going to change this fraction into an equivalent fraction with 15 on the bottom. Remember, equivalence, an equal fraction. So I need to change the bottom to 15. I have a 3, so how do I get 15 on the bottom? I multiply the bottom by 5. To preserve equivalence, I have to do the same to the top. And now 5 by 3 is 15. That's what I want. 5 by 2 is 10. Now we do the same with the right hand fraction. Well, I need 15 on the bottom. I have 5. I multiply the bottom by 3. That gives me 15. And to preserve equivalence, I multiply the top by 3. And now, because they have the same denominator, I can add the top bits, but preserve the same denominator on the bottom. Look at another one a little bit more complicated. So you'll see these types on Moodle. First thing we want to do is change the 3 into a fraction. So we write it as just 3 over 1. Keep the sign the same. I've given myself a bit more space here just to explain things. And now I don't have the same denominators. I need a common denominator. The best value to choose is 6. 12 would work, 18 would work, but 6 is the best value. And notice I've preserved the signs. So that's my first step. Lay out the common denominators and keep my signs. Now I can go in and deal with each fraction separately. I need 6 on the bottom. I have 3, so I need to multiply the bottom by 2 and multiply the top by 2. I'm going to keep going doing this, guys, setting it up. I don't go and do the maths now. I'll do that in the next step. I need 6 on the bottom. I have 2, so I multiply the bottom by 3. I do the same to the top. And now here I need 6 on the bottom. I have 1, so I multiply the bottom by 6 and the top by 6. So it's a lot easier in your head just to stay in the same little zone. And now we can do all the maths. Check first that each gives me 6 on the bottom. 2 by 3, 3 by 2, 6 by 1. They're all good. Do the top. 2 by 2 is 4. 3 by 1 is 3. 6 by 3 is 18. So I've got plus 7 minus 18 all over 6. I'll just write that a bit neater. And now 7 minus 18 is minus 11. And I just brought the minus to the front, like I said. You could write that, as we were saying, as minus 11 over 6. That would also be correct. It has the same value as 11 over minus 6, but that's the wrong way to express it. We could write it as a mixed fraction, but as I said, I don't recommend it. There's always room for error with mixed fractions. So we're nearly there now, guys. Other things you need to be aware of: square root. If you have a fraction being square rooted, the square root can actually come in and sit on the top and sit on the bottom like this. And now we can just get the square root of the top, square root of 25. What number multiplied by itself gives us 25? The answer is 5. Same, what number multiplied by itself gives us 9? The answer is 3. Now square root and square are inverse functions. We've met a few of these so far. We've met plus and minus, multiplied and divide. So square root and squared are inverse functions. They're like the hammer. One side does one thing, the other side does the other. So any rule that applies for square root also applies for squared. So if we have a fraction to be squared, the squared can go in and sit on the top and sit on the bottom. And now 3 squared is 9, and similarly 4 squared is 16. And just if you wanted to see it worked out, 3 squared is 3/4 multiplied by 3/4. Remember, in our top by top, that gives me 9, bottom by bottom gives me 16. So that, guys, kind of just sums up the introduction to fractions and a quick look at basic operations: multiply, divide, addition, subtraction, and then square root and square. So thank you, and we will chat to you again in lecture 5.